All right, section 1.2, measuring and constructing angles. The key vocabulary is what you're looking at right now. Once again, we're not going to go over that term by term right now. That's what we're going to be doing in class. So pause it, write it down if you need to. If not, keep the video playing. Next slide. Okay, an angle is formed by two rays with a common endpoint. You should know exactly how an angle is made. What we have here is an example. We have angle SRT. Now, the first thing I want to make sure that you guys are aware of is how you name an angle, okay? And so let me turn my sound off. There we go. Don't need that beeping every time. All right, there are a few ways that you can angle or name an angle. Now, notice that we have SRT. So we can actually name it angle SRT. That is our first way. Notice that the angle, if you would, starts here, goes to here, and then goes there, SRT. Or we can also label it in the exact reverse way by dealing with angle TRS. But if you notice, the middle letter is always going to be the same. And the reason it's always going to be the same is because it is what is called the vertex of the angle. So you can switch the, I guess if you want to call it the endpoint of the angle, but the vertex will always be the same. And lastly, another way that you can name this angle is you can say angle R. An angle R, when you say that, represents this entire angle. But sometimes you might be given a situation where you have multiple angles being created. So let's say if I was to add this, and if I was to add another angle or point, and we'll just call this W. Well, if you were going to use angle R as a label, unfortunately angle R would count for all of this. Okay? It would count for all of this, and technically it could count for this entire angle on the outside, which is obviously not going to be as specific as it should be. So if you're ever dealing with multiple angles, then you would want to go with the three-letter name, which is this one or this one. But if it's a single angle, which we dealt with to begin with, let me move this, then angle R would work. All right. So moving on. Measure of an angle. How do we measure an angle? Well, hopefully at this point in time in your life you have actually seen a protractor, this thing that I'm moving right now. And for those that have never used one before, let me draw a basic angle. Okay, so here is my basic angle. I did not put points on there, I just did a simple little angle. Let's look at our protractor for a second. Notice the very bottom line that I am going across right now. This line is actually very important when measuring an angle, because what you're going to do is you're going to line up that line with the bottom ray or bottom segment of your angle. And you are going to put the vertex, and if you remember correctly, the vertex is where everything comes together in the corner of the angle, if you will. That is where you are going to put the crosshairs of the protractor, and the crosshairs is where I am highlighting it or going over with my mouse, which is right there. So you are going to actually line up and put the crosshairs right at the vertex of the angle. Now, the way that you would measure this, and let's see if I have a tool that does this, is that if you notice the angle, the bottom angle line is coming right there, and the other angle line is coming right here. And what we want to do is we want to focus on where this angle is on this circular ruler here. Now we have a choice. If you notice, it is right here. Now if we were to use the ruler, so to speak, it could either be 144 degrees roughly, or it could be 38 degrees or 36 degrees. So it's either going to be a 144 degree angle, it's going to be a 36 degree angle. Well, this is where your knowledge of angles need to come into play. And if you would notice, let me make that big. Let's see if I can move this. Move that out of the way. Now you would have to determine, okay, if this is an acute angle or is this an obtuse angle? Now, if you remember an acute angle is whenever you're dealing with a measure that is less than 90 degrees. Okay? And an obtuse angle is when you're dealing with a measure that is more than 90 degrees. Okay? Now, a 90-degree angle is an angle that you would see that looks like this. And once again, I'm sure that you have seen a 90-degree angle at least once in your life. And if you are having trouble, which I am drawing it, let me try this again. Let me try this right here. There's a 90-degree angle. Okay? So in other words, is it sharper? Is the angle actually kind of sharper, skinnier than 90 degrees? If so, it would be acute. Or is it larger or broader or wider, however you want to call it, than 90 degrees? Well, this obviously is a sharper angle, so we would say that this is 36 degrees. Moving on. There are many types of angles. We talked about it last the last question. We have an acute angle. Notice how sharp it is or how skinny it is. We have a right angle. We have an obtuse angle. And then lastly, we have a straight angle. Okay? Now pause this if you need to write this down. If not, let's keep going. Example number 1, find the measure of each angle. Okay, we have AO or angle AOD. Now notice that in our diagram here we have multiple angles. So first off we need to talk about AOD. Remember that O is going to be the vertex of the angle. So if you look at O, notice that it is right here. A, which is right here, and then lastly D, which is right here. Okay, so we are going to be dealing with, and let's see if I can do this with a straight line, this angle right here. I'm going to try to draw this as best I can. Angle AOD. Okay. So if you need to see it even more, this angle right here, from here all the way over to here, it's a big angle. It already looks obtuse, but we're trying to look for the actual measure of it. So if we were to look, now notice that this is the bottom part of the angle, and I'm keeping things simple by just saying the bottom side. And if you look at this angle right here, you'll notice that, let's see, I believe this is bad quality. This is 160, 170. It looks like it's going to be 165 degrees. So angle AOD is 165 degrees. Remember, you could also say, well, it's 15 degrees, but since it's an obtuse angle, it's going to be 165. All right, next one is going to be angle COD. Now, angle COD would be, here is C, right here, there's O, and then there's D, which is right there. Okay, so now we have something that is a little different. Okay, angle COD, here we go. Let me first kind of erase a little bit of this so we can see it a little better. And so, give me 1 second to get me to catch up here. COD, that's good. We can just take that piece and get rid of it. And so, I'm just highlighting it. I'm sure you guys can see it perfectly, but it just helps me out if I can. It's going to be a little off, but this is angle COD. Now, notice that our bottom angle is not lined up with the bottom line of our protractor. So what we're going to do is we're going to take our protractor, and we're going to see if we can do this without fail. Let's see. We're going to move this. We're going to line this up right exactly on our vertex, which we did. And then I'm going to take the protractor and rotate it until it's lined up perfectly, which it is. Okay? So now, using my protractor, notice that it is lined up with the bottom line and all the way up. We notice that is a 90-degree angle, which a 90-degree angle is going to be a right triangle, or I'm sorry, a right angle. And so this is a right angle, so it is right. And as you guys know, with problem number 1, it was obtuse. So this was an obtuse angle. So if you will, go ahead and pause the video so you can figure out the rest of the exercises for 3, 4, and 5. Okay, as you can see, I went ahead and finished everything, and for 3, it is a 40-degree angle, which is an acute. Question number 4 is EOA, which is a straight line, which is 180 degrees. And lastly, EOC, which is 115. So hopefully you got those right, so let's move on. All right, the next one that we're going to be talking about is congruent angles. Now, congruent angles are very similar to congruent segments. They are just exactly the same measure, size. They're just equal. Now, notice what we have here. We have arc marks, which is same thing as like ticks when you're dealing with segments, but these are arc marks. Notice that here they are right here. Okay, and because they have the same symbol, that tells us that they are exactly the same measure. Now, let's change this up a little bit, and let's say if we had 2 arc marks. Notice that this has 1 arc mark, this has 2. Based upon the symbols here, we know that both of these are not congruent. But since they're exactly the same, which I just changed again, those are congruent. So if this was a 30-degree angle, this here would be a 30-degree angle. Very simple. Okay. The next is the angle addition postulate, which is very similar to the segment addition postulate. Very simple. What it is, if you have an angle that has been divided into multiple pieces, if you add those pieces together, it adds up to get this same, or the measure of the largest one. So like, for example, this is example number 2. It has XWZ, which is 121 degrees. Now, notice that XWZ is this angle here. And I'm going to try to highlight it as best I can. And I'm probably not going to do a good job, but there it is. So this degree here, and I'm going to say this in red, and I'm just going to use this in red. I'm just going to draw a little semicircle here, is 121 degrees, this entire angle. And let's say it says XWY. So XWY is this right here. I'm going to highlight this in blue. X, W, and Y. I didn't do a good job. It's all right. Is 59 degrees. Well, if the whole thing is 121 degrees, if this is 59 degrees, what is YWZ? And YWZ is, I'm going to highlight this in green. So basically, the green portion of the angle here, and I'm just going to label that X. So here we go. X plus 59 degrees equals 121. Well, simple algebra, really. I'm going to subtract 59 degrees, and that gives us, 62 degrees. So that means this angle is going to be 62 degrees. Please don't remember your degree. Don't forget your degree mark there. All right, moving on. An angle bisector is any ray that divides the angle into 2 congruent angles here. So notice what we have here is in this angle, LJM was the original large angle, and then we have ray JK cutting it exactly in half. And so in this example here, ray QS bisects PQR. Okay? So once again, I've encouraged you in the last video, is if you need to visually see it, please make a picture of it just to help you. Now, obviously, your picture may not be perfect, but it'll at least help you out. So PQR, once again, I know that my middle letter will always be my vertex. So PQR, and it says QS. So this is ray QS, and I guess that should be a little line because it's a ray. All right, so it says PQS, which is 5y minus 1, and PQR, let's see, PQR is the whole thing, which is 8y plus 12. And we're trying to solve for y here. Now, here's a question. I know that this angle here, I just put a dot here, and this angle here, when I add them together, it will give me the entire thing. Well, I don't know what this is. What is this angle? Well, based upon the fact that it says bisects in the directions, I know that 5y minus 1 will work for this angle as well as this angle here. So I can set it up as 5y minus 1 plus 5y minus 1 equals 8y plus 12. That's one way you could set it up. Or you could say, since this is double, you could say 2 5y minus 1 equals 8y plus 2. Whichever you're comfortable with is okay. All right, but I'm just going to stay with the top here. I'm going to combine like terms. Now remember, we're dealing with parentheses, so you take the outside and you distribute it in. And since there's nothing on the outside, it's assumed that it's a positive 1. So that becomes 5y minus 1 plus